My dear student of class 9, I am going to start chapter 8 quadrilaterals exercise 8.1. Question number 3. Show that if the diagonals of a quadrilateral bisect each other at right angles, then it is a rhombus. For the solution of this question, we write given. Let A, B, C, D be a quadrilateral in which diagonals AC and BD bisect each other at right angles at a point O. To prove ABCD is a rhombus. Proof. In triangle AOD and triangle COD, AO equals to CO since BD bisects AC at O. OD equals to OD common. Angle AOD equals to angle COD equals to 90 degree because AC and BD bisect each other at right angle. Therefore, by SAS congruence rule we get triangle AOD is congruent to triangle COD. This implies that AD is equal to CD. By CPCT we consider as equation 1. Similarly, triangle COD is congruent to triangle COB. This implies that CD is equal to CB. We consider this as equation 2 by CPCT. Also, triangle COB is congruent to triangle AOB. This implies that CB is equal to AB by CPCT. We consider this as equation 3. Also, triangle AOB and triangle AOD are congruent. This implies that AB is equal to AD. We consider this as equation 4 by CPCT. From 1, 2, 3 and 4 we get AD is equal to CD is equal to CB equals to AB. This implies that all four sides of quadrilateral ABCD are equal. Hence, quadrilateral ABCD is a rhombus, hence proved. This is the answer of question number 3. Now question number 4. Show that the diagonals of a square are equal and bisect each other at right angles. For the solution of this question, we write given. Let ABCD be a square. To prove diagonal DB is equal to diagonal CA. Second, diagonal DB and CA bisect each other. Third, diagonal DB is perpendicular to diagonal CA. Proof of 1. In triangle DAB and triangle CBA, DA equals to CB. Opposite sides of a square are equal. Angle DAB is equals to angle CBA, each 90 degree because all angles of a square are 90 degree each. AB equals to BA common. Therefore, by SAS congruence rule we get triangle DAB is congruent triangle CBA. This implies that DB is equal to CA. This by CPCT. This implies that diagonal DB is equals to diagonal AC. Now proof of 2. In triangle COD and triangle AOB, angle OCD equals to angle OAB. A pair of alternate interior angles are equal as CD parallel to AB and transversal AC intersects them. CD equals to AB sides of a square are equal. Angle ODC, this angle, equals to angle OBA, this angle. These are a pair of alternate interior angles which are equal because CD and AB are parallel and transversal DB intersects them. Therefore, alternate interior angles are equal and we say angle ODC equals to angle OBA. Therefore, by ASA congruence rule we get triangle COD is congruent to triangle AOB. This implies that OC equals to OA by 1 by CPCT and OD is equal to OB. This is also by CPCT. This implies that O is the midpoint of diagonals DB and CA. This implies that diagonal DB and CA bisect each other. Proof of 3. In triangle AOD and triangle COD, AOD and triangle COD, AD is equal to CD, sides of a square are equal. OD is equal to OD common. AO equals to CO by 1. Therefore, by SSS congruence rule, we get triangle AOD is congruent to triangle COD. This implies that angle AOD equals to angle COD by CPCT. Let angle AOD equals to angle COD equals to x degree. Now, DO stands on line AC. Therefore, angle AOD plus angle COD, the sum of these two angles is equals to 180 degree. AOD is equal to x, COD is equal to x. We write x plus x is equal to 180. This implies that 2x is equal to 180, implies that x is equal to 180 by 2, implies that x is equal to 90 degree. This implies that angle AOD equals to angle COD equals to 90 degree. This implies that diagonal DB is perpendicular to diagonal CA. From proof 1, 2 and 3, we can say that the diagonals of a square are equal and bisect each other at right angles. This is the last question today. I will meet you next day with another set of questions. Thank you very much.